Bonjour tout le monde, j'espère que vous allez bien. Ça fait toujours plaisir d'être avec Women Tech Makers. Chaque année, Khaoula et moi essayons de parler d'un sujet qui nous tient à cœur. Cette année, je ne sais pas pourquoi je suis en train de parler en français, je vais switcher en anglais. But yeah, this year we're going to talk about one-size-fits-all solutions. This is mostly motivated by AI and how everyone now is racing to use the same solutions, but it can apply to all sorts of algorithms. So, as you know, when we design algorithms, we make a lot of decisions. Now, I want you to kind of role play with me. Put yourself in this situation where you are a developer and you were tasked to develop a model that decides whether someone gets a loan or not. There's a lot of decisions that you're going to make. So you're going to have to choose which model to use. If it's specifically an AI model that you're going to use, are you going to choose a decision tree, for instance, because it's more interpretable? Or are you going to choose a logistic regression model because it's like very easy and very lightweight? Or do you want something more sophisticated, so you use a deep learning model? Or maybe you want to formulate this as a clustering problem where you cluster data points with the cluster with the people who are more likely to repay the loan and the ones who are not. Then there are decisions related to data. A lot of questions you're going to have to ask yourself. What kind of data do you have access to? How are you going to clean this data? How are you going to remove some data points where if they're like underrepresented? How are you going to normalize the data? Like if you have ranges of salaries that are too big, that's not good for your deep neural network, so you want to normalize. How are you going to normalize? Is it based on max, min, or you're going to use the average and standard deviation? How are you going to choose your features, the features that you're using? How are you going to, which credit score from which company are you going to use to kind of approximate this? And how are you going to figure out missing data? Are you going to fill them with averages, or are you just going to fill them with zeros? How are you going to do that? There's a lot to decide. Even more, when choosing also like some hyperparameters, and this is where it gets like even more random. You have to choose the batch of your data and how you're going to split it to training and tests. Are you going to do 80-20? Are you going to do 60-40? When you're going to choose the random seed, do you feel like kind of funky and you're just going to choose 6-7 because it's funny? Or are you going to choose 42 because that's what other people do? Or are you going to choose your favorite number, your birthday date? It can be anything. And it's going to be used to kind of initialize the model. It's going to be used to order the data and how it's going to be fed into the model. You're also going to choose the learning rate. And you're going to choose how many iterations you can run the model on. Do you have a lot of compute? You don't have a lot of compute? Do you have a lot of time in your hand, or do you need to deliver the model tomorrow? That also kind of is arbitrary and random. And all these decisions, they can seem small. I personally did not think a lot about these. I was always just trying things until I get a good model that has like a decent accuracy when I just started tinkering with AI. And these decisions, they can have a lot of justifications. Like, they're not completely arbitrary. Sometimes you go with a decision that is more conventional. Okay, this is the state-of-the-art model, so I'm just going to use that. That makes sense. Like, you can justify it to your boss, you can justify it in your paper, you can justify it. A decision can also be intentional. Like, I'm going to intentionally add a constraint to my training so that I can get like a certain property. I can add a constraint like adding a constraint to get more fairness among the groups that I am serving. Well, like, remember, this is a loan approval application, and I don't want to be biased or discriminate towards certain demographics. And also, some decisions can still be arbitrary, like the random seed that I'm choosing. which will initialize the model. However, when thinking about these things, we're unintentionally creating a multiverse of possibilities. And this multiverse of possibilities kind of has very different outcomes for people, even for research. When we create models and then share them in research papers, sometimes the conclusions, because of a simple thing that we failed to mention, it might not be replicable by another researcher. You know how AI is so random that, like, sometimes if I just don't tell people how I handle the missing data, it's gonna change the conclusions, and that kind of harms how research goes in the field. And so let's go back to the loan approval application. So yeah, the goal is we have the world where loan applications happened already and decisions were taken already. And the goal is to create this mathematical model of the world that kind of models the chances of repaying depending on the annual income and the credit score. Let's say those are the two features that we chose. I'm going to train several versions of the model, and there could be multiple interpretations depending on the seed that I choose, if you see in the bottom corner. I'm going to zoom in into these models. So the three models that I got, they all have the same accuracy, but they were kind of obtained using different random seeds. Which one am I going to choose? They have actually different interpretations of the data as a whole. So the first one, if you have like a higher income, you're more likely to get the loan. The second one, you're more likely to get the loan if you have like a higher credit score. And the last one, if you have higher either, you will get the loan. But individual data points, they get different stories, depending on which model I chose. So now, let's kind of think about the consequences. And to think about the consequences, we have to think about being the loan person. So you're the one applying for a loan. Yeah, let's say that's you. That's you applying for the loan. You're the little blob that we're trying to fit into a model. So for each one of these models, you're going to have a different result. For the first one, you're going to be rejected. For the second one, you're going to be accepted. And then for the third one, the model probably will be undecided, and we will delegate the decision to a human, or sometimes we're just going to do something random or look at the confidence of the model to give you a final decision. So let's assume the worst case, which is the model that was deployed is the one where you are rejected. That's the universe from the multiverse that you're in. So let's say you ask for an explanation, recourse. What should I have done to get the loan? There's actually also a lot of decisions here. The first one, let's say this is the explanation that we chose to give you. The explanation is that if you augment your annual income by 10K, you will get the loan. This is based on this specific model. But as a developer, I could also choose to give you this explanation. And it's actually more safe for me as a bank to give you this explanation when I tell you to augment your annual income by 30K and to improve your credit score by 75 points. Because as a bank, if I retrain my model in the future, my recourse that I suggested should still be the same. Like the promise that I gave you, if you come back in 3 months after improving this, you will definitely get the loan. It should be something that, even if I retrain my model, it's more likely to stay the same. However, for people, this means that we have to conform. We have to become like a certain majority that got the loans before, and that would mean necessarily that it's making it hard for some people, depending on the features that we've used, to kind of obtain these opportunities. And so I just wanted to remind you that there are a lot of decisions throughout the machine learning pipeline that lead to different outcomes for individual data points. From thinking about the viability of the project, to formulating the problem, to collecting the data, up until the evaluation, we will have different things that impact the outcomes. And so I like to use this quote by Kathy O'Neill from Weapons of Math Destruction, which says, models are opinions reflected in mathematics, which is very true. I believe that whenever we make some decisions, when I decide which data points to remove, that's mostly an opinion. But like to think about the consequences of a model, and this arbitrariness in the models, we have to think, is it a field where we only have one shot? This applies when, for example, if I'm making a model that is like for a government organization, or if it's like for multiple hospitals, where if I have an error in my model, it's gonna become systemic. If I have an error and I'm making a model that's gonna be used where people are only having one shot at something, and I'm always rejecting them because of something very arbitrary, then I'm kind of ruining everything for them. If it's like government jobs, if it's hospitals, that's kind of a very difficult thing to make. But if we have some diverse institutions, like maybe like different banks are using different models, they have like different things that they want to prioritize in their models, some want to promote themselves as more inclusive, some want to make specific offers for some specific demographic groups, then in that case, maybe you are more likely to get a chance elsewhere. However, nowadays, everyone actually uses the same models. You know, with ChatGPT, it's very easy. It's easier to just call a model through an API rather than like train the model yourself. And it's easier to kind of just for the companies to ask for a company like HireVue, which specializes in scanning CVs and hiring candidates, to kind of, everyone just uses the same service. And so if someone is rejected by one, it means they are going to be rejected by everyone. And so now, what was once arbitrary, but in a way that is inconsistent, has become very standardized and consistently arbitrary. And it's this homogenization that Khaoula is going to talk about. And she will tell you more about how it's happening and how it's kind of spanning out of our control. Thank you.
Hi, everyone. I'm Khaoula. I'm doing a PhD in how to better evaluate language models for their societal impact. So today I'm going to talk a little bit about that, about like what Afaf presented, what it actually means in practice in the case of language models. So with Afaf, we have seen that we moved away from having like all these different solutions leading to a wide range of models into having only mostly a few models being used. And what this means is that you have like, if you go online, you can see a bunch of funny examples of like, for example, people asking a different of language models for a random number and always getting the same number, which is 17. Similarly, there's a lot of things happening with people asking language models for a joke and almost always getting the same joke, even if they look at different providers. So this is what we call outcome homogenization. And in some cases, it's trivial, like for a joke or a number. But in other cases, for example, with the HireVue example that I've presented, it can be problematic because it means that all your models across all providers are doing the same thing. It also means they are excluding the same things. So there's a lot of studies that have shown how these models have gender bias, racial bias, and it's all the same stereotypes across model families. There's also a lot of work on novelty and creativity because these models are being more and more used to replace human artists, for example, or just humans in general in their work, but there's a convergence towards the output being produced. So we have less and less creativity. And there's also people who have led interviews and have shown that these models also influence the way you think. So it's not even a writing problem anymore. Thoughts are being homogenized and westernized. So when we talk about homogenization in machine learning, some researchers say that we got 3 waves of homogenization because we went from having specialized solution to specific problems into having like algorithm that it's basically one learning algorithm that can be used for a variety of tasks and in a variety of application with logistic regression, for example. Then we went from machine learning to deep learning, where we got even more homogenized because at least algorithms like logistic regression needed people to create specific features for their applications. Whereas with deep learning, you just need data. You don't need to engineer anything. And then we got into the third wave, which is the worst, which is the foundation models. And basically, we talk about transfer learning paradigm, and what it means basically is that there's only a few models being trained, and then they are adapted for the application, but the base is the same all over the place. So for example, if your employer is using a language model internally, it's probably powered either by Gemini or ChatGPT or Claude, etc. So to explain this wave of homogenization, researchers talk about something called the component sharing hypothesis. And it's basically the fact that you don't need to have exactly the same model to have homogenized output. Just sharing some components is enough. So if you train on the same data, which we know it's happening because these models are being trained on like everything on the internet. So even if you go into different models family, we all know that they have a big overlap in the data set. If you share the same training strategies, and we know they do, then you're more likely to have homogenized outputs. But most of the work that have looked into outcome homogenization and algorithm monoculture, which is when you have like one model all over the ecosystem, has mostly looked at it from okay, I understand now. Has mostly looked at it from a technical perspective. They have looked at how these models technically lead to homogenized outcomes, but we know that AI systems are socio-technical systems. So they are like, we have this idea that AI is a little not really materialized, whereas we know it's not true. Like AI models are basically, they rely a lot on infrastructure, on like compute, for example, data set, human labor. So all these components are usually not talked about when we talk about outcome homogenization. So in my research, we were interested to see like the relationship between the AI system as a whole through its AI value chain, like how the system is produced and how we end up with homogenized outcome. So I'm going to present my most recent work on the topic, which is basically how the AI value chain drives LLM homogenization. And we're going to go through each element of the value chain and explain a little bit how it contributes to the fact that if you ask ChatGPT or Claude for a joke, you'll have the same answer, most likely across like various possibilities. So the first thing is the actors. So training language models that have the similar capabilities to the leading language models today takes billions of dollars. So there's not a lot of people in the world that actually can do that. So when you look at actually LLM providers, there's very few of them. There's dozens all over, and it's mostly like big tech companies. We have a few startups, and elsewhere it's like states that have invested into actually training a language models from scratch. And these pre-trained language models are being used by the rest of the world. So when you don't have a lot of players, it also means that you don't have a lot of diversity. Because if you have only a dozen models to choose from for the rest of the planet, you're more likely to end up with models that systematically exclude certain group. We realize that this monopoly is not only for LLM providers, but everyone else in the supply chain. So these models, they are trained on like they need GPU. They need a lot of compute to be trained. And there's NVIDIA, which is I think they have 90% of the market share of the chips designs. So you have only one suppliers for all these companies, mostly. And these suppliers only have only one supplier. I think there's like the manufacturer that develop what you actually need to produce these chips. It's called ACML, and there's only one company in the world that does that. Like they're the sole manufacturer in the world of the chips you actually need to design state-of-the-art language models, which is the H100. There's a lot of people trying to design different chips, but for now they're not as competitive. So it's the same thing for the data vendors. To train this model, you need data, you need good quality data. There's only a few companies that create good quality data, and their clients are all the LLM vendors. When we looked into these players, so you don't have a lot of big companies, and most of them, they have a common history. So what it means is like DeepMind was first created in 2018 and then acquired by Google. Then Anthropic was created by some Google employees that were not happy with what DeepMind was doing. No, sorry, this is OpenAI was created by DeepMind employees, and then Anthropic was created by OpenAI employees that wanted to diversify because they were not happy with OpenAI mission and the fact that it was less and less focused on safety. Then XAI was created by Elon Musk, which is the main investor in DeepMind and OpenAI in their creation. Similarly, Mistral, which is the French language models, was created by people who were working at Meta. So you already don't have a lot of actors, and we realize even inside these actors, it's basically the same persons. So this also drives more and more homogenization, because if you have like 4 investors in the world, and maybe 5 companies that used to work for which the founders were working in other companies, you can imagine that there's a lot of limited possibilities of the diversity you're gonna obtain from that. Similarly, another thing that we realize is that it's really hard to have new entrants in the market, because there's a lot of barriers to entry. Mostly, like if you want to be a player in the infrastructure market, you need crazy infrastructure. You actually need, for example, for data, you need data centers all over the world. For compute, it's a very saturated market. And similarly, to create LLMs, you need a lot of money. But there have been some few AI startups that have tried to come up with either new models, either new infrastructure, or like new hardware. And basically what they realize is that, what the researcher realized is that they were what they call acqui-hire. So to prevent, like to have a healthy market, you need competition. So there's a lot of regulation that were created to ensure that companies cannot actually acquire the competitors. So big tech found a way around that, and it's called acqui-hiring. And basically what they do is that instead of buying the startups, because they're not allowed to do that, they hire the CEO and the employees of the startup. And they have a non-exclusive license. And what happens is that once the startup has no more staff, because everyone moved to Google or Meta or OpenAI, the startup just dies. And like they acquire basically either the innovative design or anything that startup was applying. So basically, we've seen that we don't have a lot of players. They're the same people, and they don't let anyone in. Because it took so many resources and investment to get at what they are today, there's no incentive to have more players in the market. So we talked about the actors of the supply chain. Another important aspect is governance. What are the missions, the values of these companies? So because there's a lot of overlap between these companies, there's also a lot of overlap between their ideologies, their mission, and what they want to give to the world. If you look at most of the mission of these companies, they often talk about the fact that they want to benefit all humanity, which looks nice. But if you look at the history behind that, mostly like most of the CEO and the investors, they're part of a group of philosophy from the Silicon Valley, which is like effective altruism, long-termism, and there's a bunch of them. And basically the idea behind these philosophies is It's like mathematic radicalism. You need like to optimize happiness. So there's, some of them are more philanthropic, like effective altruism, but they rely on this very mathematical notion of optimizing. So the idea is only to invest in projects that can have a maximum impact. And a way a lot of these founders have interpreted it is that if you're able to accumulate a lot of capital, then you're also able to give more and benefit more the community. So with these technologies, there's two main ideas that come from. There's a lot of techno-futurism. There's this hard belief that AI and AGI, artificial general intelligence, will lead the world to utopia. So it will fix, having a very intelligent system will fix all the problems that we have today, like with a sickness or poverty over the world, this type of thing. There's an essay by the CEO of Anthropic called Machines of Loving Grace, where he talks about this vision of world utopia. And there's also the other side to this philosophy is the catastrophic, like the dystopia version. So basically the idea is that if we develop great system, we'll have utopia, but if someone else does it that is ill-intentioned, we'll have the end of the world. So it's really important that we're the one who develop the system because we're the good guys. So that's the prevalent ideology, and that's what's, something we also noticed is that, so recently with Trump, because most of these companies are American-based, so there's a lot of things that change depending on who's in power in the US. And with the Trump administration, we had like a shift of all these companies into the far right. Whereas before that, they were more left-leaning because they wanted to be associated with Hillary Clinton and Biden. And recently, they swear allegiance to Trump. And you can see it when you look at the models, like the recent models being developed. You have things that we don't want our model to discriminate against people, so we don't do fairness, because fairness is basically discrimination against white people. We think our model, I think in Llama 4 blog post, you can see something about the fact that the previous models were too woke, so they needed to correct for that. So you can see it, and it's all happening at the same time for all these companies. So even when they switch ideologies, they all do it at the same time. And the issue with that is that they have a lot of power to spread the narrative. So we know, for example, there's a lot of political lobbyism happening in the US to not have any regulation for, I guess, bias and environmental risk of this model, and instead have regulation for the catastrophic risk, which are, even if you believe in them, they are still like a small probability of happening, whereas all the other harms are very documented and have been documented for the last decades. So they have a lot of influence in politics. Some researchers realize that the people working in the policy department of these companies used to work in the White House, so there's a lot of overlap there. They have a lot, we talk a lot about corporate capture, there's a lot of reach on the media. They get, since they invest or even own a lot of the media companies in the US, they get to dictate the narrative about AI risk, about what really matter and what we should care about. And they also have a lot of influence on academic research. So I do academic research, I'm at McGill and Mila, and you can see that most of the grants that professors have, they come from either Google or Meta or OpenAI or Anthropic, depending on what you work on. Same thing, if you want to get published, you need to talk about these topics. If you're not working today in LLMs, it's getting harder and harder to have like a place in AI. So there's also homogenization happening in the type of work that is being done. So now that we've looked a little bit who was leading these companies, to create an AI model, we have seen that you need a bunch of resources. The first one is the hardware resource. And this need for hardware resource actually shape a lot of the decision being made in how you construct this model. And that's why you can see every day that there's a new deal between OpenAI, for example, and another company. Because they're trying, all these companies are trying to acquire more compute resource because it's a really a rare resource, and like NVIDIA really has a chokehold on the market. So they're trying either to find new suppliers or build their own infrastructures. Like Meta, for example, is investing massively into creating data centers, creating chips so that they're independent at this level. And the compute you have access to is going to have a huge influence in the type of model that you're going to develop. DeepSeek is a good example because China did not have access to NVIDIA GPUs, I think it's the A100 and H100, which are like the best GPU needed to create LLMs. So they had to diversify differently, like they had to come up with a new strategy to train an LLM, and that's how we got DeepSeek, which is more different than the other LLM, even if still very similar because they used American LLM as like teacher models. So compute really has like really decide what type of decision you're gonna make when training these models. And we have seen like a lot of researchers have seen that there's a compute divide. So similarly, not everyone has access to compute. And like every other resource in the world, it's like, you have like most of the Western world and North America, so in the Western world that has access to enough compute to train models. Then you have in red, so in the blue, you can see it, in red, you have countries that have access to compute, but only to use the models, not to actually train them from scratch. And then everything else in the world is a compute desert. So this means that even if you got the money to invest massively in LLMs, you won't have access to compute because it's dominated by a bunch of players. So if you want this access, you'll probably still be relying on existing players. Similarly, you need data set, and we have seen earlier that there's only a few big data set providers that are being used by every LLM vendors. So this does not create a lot of diversity if everyone is training the model on the same data set. And even within the creation of this data set, we have seen that there's not a lot of diversity, because usually what happens is that even if they have data centers all over the world, like they have data centers in like African countries, in Southeast Asia, and like in Latin America, so you would think that at least having more people with different background be involved in the data creation process will lead to more diversity. But because of the process, it does not actually happen. Because you have, so workers, data workers, there's a lot of studies that they have shown that they work in very bad conditions. And because of the poor condition, there's not a lot of incentive to, I guess, innovate and do something differently. Because they're being surveyed for the work that they do, they are expected to achieve certain metrics of performance that are determined by the company. And they get fired if they don't, and given their socio-economic condition, they cannot afford to get fired. And basically what researchers have shown is that like something like the data instruction, like the whole process into creating data is very constrained by the companies. Like the instructions are very defined and very westernized. Like for example, this is about, they're asking people to label the race for different data points in a data set. And the categories are white, African American, Latinx or Hispanic, Asian, Indian, ambiguous. So this is given to annotators in Venezuela, for example. And they need, which does not make sense, like the race categories are very Americanized. It does not make sense for someone from Latin America to have Hispanic or something like that. And they are asked just to fill that and being evaluated on how good they fill categories like that. So what we realize is that the few diversity that could have come for having people from other countries, even if like the whole process is in terrible condition, does not actually exist. So another thing that comes from, that is needed to train a language models is workforce. So there's a need for workforce at the whole level, but we actually looked at tech workers. We were very interested into tech workers because we have seen earlier that a lot of this company originated from the same people. So we know that the founders have worked everywhere, and we were interested in knowing if the people who are working now have also worked everywhere. And basically, when you Google the AI talent war, you realize that like tech workers are that can train LLMs are really considered as a scarce resource. So what companies do is that they directly poach them from other companies. And when you look at the language models report over the year, you can see, you can actually recognize the name of the people that, for example, were in the first GPT-3 model are now in Anthropic, or that were in the Llama model are now in Mistral. So these models are being developed by the same people, and even when they are not developed by the same people, they are being developed by the same kind of people. So we know, for example, that there's not a lot of women in the field, even less women at this level of competitiveness. So the fact that there's so few actually tech workers that develop LLMs contribute to this homogenization, because instead of having a multiverse of possibility of how a model can be trained, all the models are being trained by either the same people or people with similar background. So then we have seen like the different step of the AI chain, and we have like the AI system. And the way these models are being developed, we're gonna zoom in into it, is for the last years at least, now people are starting to converge, there was this idea of scaling. So you needed bigger than ever models to be able to achieve AGI, which is this super intelligent system. So you needed more data, more compute, more parameters. So because of the huge scale of the thing, it's really hard to have like a personalized solution. Usually you go, like the goal was to have a general purpose system, which means a system that can do everything. And what we realized with all the failures documented of these models is that they can do everything, but not very well. So there are some tasks like writing, for example, they're good at writing, but if you use them for math, they are terrible. If you use them for a specific application, they are terrible, which is normal because they were trained to do everything, but it's not like without the actually expertise or knowledge or what it actually takes to make a task happen. So because of this general purpose philosophy, we ended up with very few personalized models, and models that were optimized for the majority. And the majority in a North American context, like in a westernized world. And so that's why we end up with models that always discriminate against the same minority, which is supposed to be the majority of the rest of the world. So like we've talked about this ecosystem, and like basically I'm just going to give a few examples more technically what it means, what it looks like when you're training a language models. I work on safety evaluation. And what I realized over the year is that like people, all the companies are more or less doing the same thing to mitigate these models. And at the end of the line, these models are still biased. So why are they imitating each other if it's not working? And basically the pipeline most of the companies have emerged towards to do safety homogenization is like I guess 5-step is a simplification, but like you can decompose them if you want. But like, first of all, we know that they train on a huge amount of data. Because of the size of the data set, it's not actually possible to clean it properly. So they do automatic data filtering. Usually they try to do this filtering for like very toxic content, pornographic content, child abusive content, and also all the websites that have a lot of personal identifiable information. But we know that even despite the filtering, the data sets are still problematic and the models still have this bias. Then there's the pre-training. So pre-training is where all the model learn all its knowledge. And here, usually there's no intervention because it will be too costly to do something at the pre-training stage. Pre-training is just basically just a model learning to predict the next word on a huge amount of text. And that's how you get the language models that we have today. Once language models know how to write, then we have the extra safety step. We first have fine-tuning, which is basically giving a language model. For the case of safety, companies create safety data set with example of harmful prompts, something, for example, asking, a Muslim terrorist, and like a demonstration, like how the model should answer in such a case. And then the model is trained on that to learn how to answer properly this type of questions. And then you have the reinforcement learning with human feedback, which is how we got to the models that we have today that are so capable, because in this phase, model learn to output text that is pleasable to humans. And the way they do that is that it's just a training process where you have humans down the line that label model outputs and that they say, oh, this is a preferred output over the other. And the model learn to optimize toward the preferred output. And in the cases of safety, they do that with harmless preference, meaning that you have a harmful prompt to answer one that is desired, the harmless one, and one that is less desirable, so the harmful one. And the model learned that in this context, you're supposed to give a harmless answer. And then at the last step, you have the evaluation. You have trained your model. You want to make sure that it's safe and robust. And basically, we realized that all these companies had the same pipeline, despite all the safety failures being documented. So they are copying each other, even if it does not work very well. The other thing we realize is that within the safety pipeline, they all share the same artifacts. Some of them are academic, other produced by industry, but basically what it means is that they're gonna use a risk taxonomy and they're all gonna look at the same thing. They're all gonna define the harms of the model in the same way. Similarly, they have a big focus now on catastrophic risk, so they have this preparedness framework, and they all look the same. You have a bunch of benchmarks that are known for safety. They're all going to evaluate their model on the same benchmarks. And we could think this is good, this is standardization, but what we saw in practice is that because of all the issues that exist with these artifacts that they are sharing, they are just trying to replicate the leader. So the leader, in terms of capabilities, is OpenAI, and in terms of safety, at the time, now we see the new models are doing better, and in terms of safety, it's Anthropic. So basically, when you read, for example, if you go through a Gemini report, you can see that they're trying to imitate Anthropic in the safety part. When you go to Llama's report, you can see that in certain part, they're trying to imitate OpenAI. The issue with this is that OpenAI and Anthropic and all these companies, they do not really disclose what they do. They only disclose the bare minimum. So these companies are actually imitating each other, but without knowing what happens behind the line. So this, when we saw this, we were like, okay, maybe this is from where the diversity will come from the fact that they're not able to imitate each other because of the lack of documentation. So they are forced to do things differently. And we have seen that doing things differently can lead to a multiverse of possibility. So the issue when we looked into this is that we realized that for the things that were done differently, it was not necessarily a good way of doing things. So for example, we know that Anthropic, since their mission is very focused on effective altruism, and they try to do good, they have a lot of rules on how to treat the data worker. They ensure that there's diversity in the workers, that there's a minimum wage, this type of things. And this could be a practice, it's a good practice, but this is not the type of practice that is being imitated by everyone else. Usually what is imitated, it's more the very cost-effective practice that make a big superficial difference. And evaluation is one of them. Evaluation practice is one of them, because we realized that these companies, so all these companies are trying to sell you a project. And you're asking them to evaluate this project and be honest about the capabilities, the risk, this type of thing. But they have an interest. They want to show you that they have the best model possible. So there's a set of benchmarks that everyone used to show that this model have the best possible capabilities. And the way it's implemented is that it's almost like an optimization objective. So you have all these models being trained. At the end, they try to converge to have the best result on the same benchmarks. And there are things in each company that happen differently. And one of them that happened differently is all the evaluation practices because of the lack of difference. But what we realized is that the evaluation practices were a little random. And an example that really shocked me is that I don't know if you've seen the news. It was a couple of months ago. There was a big issue with ChatGPT it had like a sycophancy problem. Sycophancy is what happens when the model confirms your worldview. So it's basically a feedback loop. You say something to ChatGPT, ChatGPT is like, this is the best idea I ever heard, and you should do that. So this is what they call sycophancy, and like ChatGPT, OpenAI released a version of ChatGPT that had a huge sycophancy problem, like huge, like wider than usual, because we have seen a bunch of news with teenagers having mental health problem and psychosis break because of these models. So this model was terrible, so they actually had to remove it from the market. And they wrote a blog post to explain how such model was actually deployed and what they do in terms of evaluation. And basically what they were explaining is that they were like, oh, when the model is done, there's some A/B testing. And we also do something that we call vibe checking, where we interact with the model. If we have a good feeling, we release it. So for me, it was really scary to read that, because I'm like, imagine like a pharmaceutical company giving like a drug to the market, and when you ask how they test it, they say they vibe checked it. So this was like traumatizing, and we realized that a lot of reports had this type of sentence, either vibe checking or saying things, oh, most of academic benchmark don't give a lot of information on fairness, so we don't report fairness evaluation. So we had all these different things, so we were like, even like the hope that we had that where they are not copying each other, they're doing something good, we realized it was mostly the opposite. It was either they were trying to have the best practice defined by like Anthropic, OpenAI, things like that, or they were really doing random things on the side. So this was a very pessimistic talk, but we want to end up on a good note, is that because of the cost it takes to train models, and because the market is being saturated, and even this language model company are not making that much money from the use of people, because it also costs a lot to run these models. So they're mostly paying everything in compute. There's a lot of people trying to come up with their own, either their own project with their own like community-based initiative. There's a lot of work, for example, happening in low resource languages, with community being like, we don't want these large language models that are exploiting our data set and are not even working properly for our language. We want to create our own initiatives. There's also a lot of things happening in the academic sector. I know that like in Swiss, they created like their own language model, and it's basically a collaboration between hundreds of institutions. So there's the thing that maybe as your own entity, you cannot compete, but like if you collaborate, if you have more community-based project, then you can bring more diversity. And because we've been seeing a plateau in the capabilities specifically for a certain task, people are starting to understand that specialization and expertise are important. So a lot of people are moving away from the scale is all you need narrative to actually get specialized models, like I guess back in trends. So there's a lot of things happening in the ecosystem to produce more diversity, to avoid like the algorithmic monoculture. That means that if you're discriminated by one model, you're gonna be discriminated by all versions. But there's still a long way to go. Thank you, and you can add us on LinkedIn if you want to talk, and we're also gonna be here for the rest of the day.